Dear students, in this video, our topic of discussion is going to be slope of a line and its application in physics. Before we get started with the main context, let's try to take an example into consideration. See, we would have seen a scenario where a car is moving on a level road and sometimes a car would be moving on an elevation either in the upward direction or in the downward direction. So, the elevation which I am trying to talk about is what is called as a ramp. Okay. So, technically we can also say that the car is moving on a ramp or a slope. So, basically this is the place from where the term slope comes into picture. So, first we need to understand what a slope means. Slope in simple terms means a surface which is not level. So, having this point in mind, let's take the definition of slope into mathematics and analyze the same thing for the coordinate geometry and derive a formula for it. Let's get started. So, according to mathematics, there are two important points that you need to remember before we start with the definition of it. First thing, slope is also called as gradient. Secondly, slope is defined only for a straight line. From this, we can say that slope of a particular line is given as the tangent of the positive angle made by the line with the x-axis. So, here if you observe, I am concentrating on one term, that is the positive angle. So, for that we need to understand what a positive and a negative angle means. Basically, when you try to measure the angle between two lines, you can measure the angles in two directions. So, one of the directions is going to be anti-clockwise and the second is going to be clockwise. So, understand, according to physics and math, any angle measured in the anti-clockwise direction is taken as positive and the angle measured in the clockwise direction is considered to be negative. So, the definition of slope clearly tells that we need to find the tangent, that is tan of the positive angle, that is the angle made with the x-axis in the anti-clockwise direction. So, having all these points in mind, let's try to take this and apply it in the coordinate geometry and derive a formula for it. Now, suppose I consider the x-axis and the y-axis and I take a line which is making an angle theta with the x-axis in the anti-clockwise direction. So, on this line, I am going to consider 2 points A x1, y1 and B x2, y2. From here, from the point A, I will be dropping a perpendicular onto the x-axis. So, the distance from the origin to the foot of the perpendicular drawn from the point A onto the x-axis can be called as x1. Similarly, from the point A, if I drop a perpendicular onto the y-axis, the distance from the origin to the foot of the perpendicular on the y-axis from A can be called as y1. Similarly, from the point B, if I drop a perpendicular onto the x-axis, the distance from origin to the foot of the perpendicular from point B is x2. Similarly, from B, if I drop a perpendicular onto the y-axis, the distance from the origin to the foot of the perpendicular on the y-axis is y2. Now, if you observe that you have the distances x1, x2, y1 and y2 on the x and the y-axis respectively. We need to take all these distances into consideration and try to derive a mathematical expression for slope. So, from the basic definition of slope, we are able to understand that slope is nothing but tan theta. Now, we know that tan is a trigonometric function. So, wherever trigonometry is involved, the only way we can solve the problem is by looking for a right angle triangle. But if I look at the diagram, I do not have any right angle triangle. So, it is our job to construct the right angle triangle. So, for that what I am going to do is, from the point A, I am going to drop a perpendicular onto the perpendicular from the point B, so that these two lines meet at a point P where it forms a 90 degrees. Hence, I got the perpendicular. Now, I am able to clearly see that A, P and B forms a right angle triangle and AP is nothing but x2 minus x1 and BP is nothing but y2 minus y1. Now, if you observe, AP is a line which is parallel to x-axis. Since AP and x-axis are parallel to each other, the line that we have considered is going to act like the transversal. So, when the transversal makes an angle theta with the x-axis, the angle it is going to make at point A is also going to be theta, because these two form the corresponding angles. Now, having this diagram in our mind, if I take the triangle APB and write the formula for tan theta, where tan theta is nothing but opposite divided by adjacent, which is nothing but BP divided by AP, but we know that BP is nothing but y2 minus y1 and AP is nothing but x2 minus x1. So this y2 minus y1 is what we call it as the difference in the y coordinates, and x2 minus x1 is what we call it as the difference in the x coordinate. But according to the definition, we know that tan theta is nothing but the slope. So slope of any straight line is given as the ratio of the change in the y coordinate to the change in the x coordinate. In mathematics, slope is represented by the symbol m. That is, every time you need not sit and write it as tan theta, rather you can write it as m. Now we will discuss about the applications of slope in physics. For that, let's consider an example. Let's say there is an object which is at point A and given an initial velocity u, and the object after time t, let's say it has traveled a distance t, and at a point B it is having a final velocity v. Now, from your lower grades, you would have learned the equations of motion for an object under constant acceleration. Assuming that this object has moved under the constant acceleration, we can say the relation between v and u is v is equal to u plus at, which is the first equation of motion. Now, since we need to see the application of slope in physics, let's try to approach it graphically. That is, if I take the velocity on the y-axis and the time on the x-axis, and we try to plot a graph between both, we clearly know that the graph represents a straight line with the starting point as 0, u. So it is going to be a straight line in the upward direction. So what is slope? Slope is nothing but the ratio of the difference in the y coordinates to the difference in the x coordinates for a straight line. Here also, if you observe, v is equal to u plus at is representing a straight line on a graph sheet. So we will take any 2 points, where one of the points that I am considering is 0, u, and the other point that I will be considering is t, u plus at. Now, if I take these 2 points and try to find the slope of this particular graph, I will get u plus at minus u divided by t minus 0, because u plus at is going to be y2 and u is going to be y1, and t is going to be x2 and 0 is going to be x1. So by applying the formula, you get u plus at minus u divided by t minus 0, which is nothing but at divided by t, and t will get cancelled, which is going to give us the acceleration. So it is very much clear from this particular example that when you have a velocity time graph and you want to find the slope of a velocity time graph, according to maths, it is called as slope, and according to physics, the slope of a velocity time graph is going to give you the acceleration. Now, you can ask me a question, is it going to be the same scenario if I consider 2 other random points on the straight line? The answer is going to be yes, and this part I am leaving it to you people to explore, and you can find out the answer and let me know in the comment section.